electrolysis. So, without wasting much time, we are talking about electrolytic cell. So, this conception is based on one very wild aspect of chemistry called electrochemistry. In electrochemistry, we have a number of conceptions that are discussed, one of which is electrolytic cell, which encompasses most discussion under electrolysis. So, technically, we shall be talking about electrolysis. So as we progress, I'll be asking questions, and when answers are requested from from you, I want you to to get yourself unmuted and give me answers to these questions as we proceed. So, what is electrolysis? Do you have anybody who has an idea of what electrolysis is? Let's hear from anybody. What is electrolysis? I'm all ears. Just give it a try. What is electrolysis? Anybody? Anybody? What is electrolysis? Anybody? Okay, no problem. Let me continue. I think you have been unmuted. You have been muted. So let me proceed. When it gets your time, okay. I think somebody was about to talk. Okay, let me proceed. Now, the word electrolysis comes from two words that we can see here. We have electron, electro, and then you have lysis. Electron comes from electricity, and lysis simply means to split or to break. So what should come to our mind when we say electrolysis is the use of electricity to split. So what are we using electricity to split? So that's just etymological meaning. But when you are to go into the conceptual meaning of what electrolysis is, so what does it actually mean? This is a process whereby direct current enters into a solution of electrolyte, leading to its decomposition into constituent ions. That is what electrolysis is. What do we mean by that? When you have a solution and you pass direct current into that solution, note the type of current that is passed into the solution is direct current. So when you pass a direct current into such a solution, and such solution splits and decomposes into its constituent ions, this process or procedure or phenomenon is called electrolysis. For example, if you have a solution of sodium chloride, or let's say a solution of water, which is H2O, and you pass electricity into it, what happens? If H2O can at the end split into its constituent ions after direct current has been passed into it, the ions making up H2O are H plus and OH minus. So if at the end of the process, after passing direct current into H2O, you have been able to split the water into H plus and OH minus, we call that process or procedure or phenomenon, we call it electrolysis. Now, electrolysis occurs in an electrolytic cell. So there is a setup which holds the process of electrolysis. That setup is called the electrolytic cell. So the electrolytic cell is made up of a pair of electrodes. We have two electrodes. One is positive and the other is negative. And in addition to that, we have an electrolyte. The electrolyte is always molten or liquid in nature. So, and it's held in a suitable container. So the setup making up an electrolytic cell is constituted of the following. We have a pair of electrodes, that is a positive and a negative electrode. We have the electrolytes, which conduct electricity, and in addition, we have a container and possibly wire and battery. So all these setup comes together to make up what we call the electrolytic cell. I remember the video that there was a question some years back in WAEC where they were told to I think explain or talk about electrolytic cell or divine. I can't really remember the conception. So it's a setup of electrolysis, right? Which is made up of the following things we talked about. You have a pair of electrodes, positive and negative. You have electrolytes. You have a source of battery, and possibly you have a wire. All these setups helps in making up the electrolytic cell, and the process of passing electric current into the electrolyte, leading to the splitting of such electrolyte into its constituent ion is what we call electrolysis. Now, the electrodes are poles or plates through which the current enters and leaves the electrolytes. That's what we call, those are the electrodes. Majorly, electrodes are always in solid form or in hot form. As you can see, they are poles or plates. They are always in solid forms. And they serve as a conductor uh, that helps in transmitting electric charges or currents from the source of the battery into the electrolyte. You're going to see a setup of that nature. So the electrodes can be of different forms. They can be metals or graphite. They can even be non-metals too, like graphite is a non-metal, right? We can also have some other ones which could be active and some which could be passive. We'll talk better about what makes an electrolyte active and what makes an electrolyte passive in our subsequent discussion. So here, the anode is also an example or a form, a type, a category of electrode. Just like we said electrodes are poles or plates. And in our discussion, we said for you to have an electrolytic cell, you need a pair of electrodes. That means a positive electrode and a negative electrode, making a pair of electrodes. So these electrodes are of two major forms or types. We have the anode, right? And we have the cathode. So the anode is the electrode through which the current enters the electrolyte. So that's the portion where electric current enters into the electrolyte from the battery source, right? So it is positively charged. So the anode electrode is a positively charged electrode, and because it is positively charged, it's going to get itself attracted to anions. According to the law of electromagnetism, like poles repel while unlike poles attract. So the anode, which is positively charged, will have a great tendency to attach itself to negatively charged ions, which are called anions. So anodes, which are positively charged electrodes, will get themselves attached to anions, which are negatively charged ions. So note, anodes to anions, right, and cathodes to cations. We get to cathode soonest. Anodes generally undergo a process called oxidation reaction by losing electrons. So the common reaction that is found in the anode series is what we call the oxidation reaction. And there is a simple analogy used for that, if you want to know that. Is the acronym is CRAO, C-R-A-O, C-R-A-O. You can put that down somewhere so you won't forget. It's just a shortcut for you to know the common reactions that occurs at the electrodes. CRAO, that's CRAO. So the C here stands for cathode. So at the cathode, what occurs is reduction. So CR, cathode for reduction, and anode for oxidation. Cathode for reduction and anode for oxidation. So we call it the CRAO system. So it's just an acronym used to connote the reactions that are very pertinent to the electrodes. Okay, I hope that is clear. Next, yeah, you can see the diagram here. This diagram is actually revealing to us the process involved in electrolysis. I'm going to use that to quickly explain what we have been talking about. Here we have the direct current. Yeah, so direct current helps in uh, as a source of electricity, which is passed into the electrolyte. Okay, the electrolyte is down here, and you can see the two electrodes. One is there, and the other one is here. So this one here is the cathode, and the other one here is the anode. And down here you have the electrolyte. As you can see in the electrolytes, you have positive and you have negative ions. These ions came to be because electric current has been able to pass through the electrodes down into the electrolyte, leading to the splitting of the electrolyte into their constituent ions. So the positive ions, which are called the cations, will migrate to the cathode. Don't forget, the cathode is said to be um, negatively charged. The anode is said to be positively charged. So because the anode is positively charged, the only ions that can get attached to it will be the anions, because unlike charge attracts, while like charge repel. So the cathode here is negatively charged electrode, so the cations will have a great tendency to get themselves attached to it. So this diagram shows us a simple principle or description of electrolysis. So the setup here is known as an electrolytic cell. So here is an electrolytic cell which contain all the components used in electrolysis. And with that, we've explained what electrolysis is all about and all each of their components. Lastly, the one I didn't talk about, which apparently I mentioned while I was making my explanation, is the cathode. The cathode is the electrode through which the current leaves the electrolyte. So don't forget that the anode is the portion in which the current is entering into the electrolyte, while the cathode is the portion in which the electricity is leaving the electrolyte to complete the circuit. So the cathode, as I said, is the negatively charged electrode, and because it is negatively charged, it will get itself attracted to the cations, because cathode is negatively charged, cations is positively charged. So, and in addition, I've also said that reduction is the general process that occurs in the cathode. So, at the cathode end,
I'm having class.
We have agreed she will go and throw it.
Yes.
Whoever is washing his own through.
please, where is that noise coming from? Please get yourself muted.
Sir, can you unmute?
Okay, fine. I hope you can all hear me now, right? Okay, here we have reduction. As I said, reduction is pertinent to the cathode. So reduction process occurs at the cathode, while oxidation occurs at the anode. And usually the cathode is assigned a negative, is attached to the negative terminal of the battery, while the cathode is attached to the positive terminal of the battery. So the mechanism of electrolysis. What is the mechanism involved in electrolysis? Now, an electrolyte is composed of positive and negative ions and conduct electric current in molten or fused states or when dissolved in water. Generally, when we talk about electrolytes, what we are actually discussing or making reference to are substances in liquid form or substances in molten form, right, which has that tendency of conducting electricity. We call those substances electrolytes. For example, when you have sugar, when you have a solution of salt has high tendency of conducting electricity. So that's why it is always said never urinate where you have a transformer, because it is very possible that while you are urinating, the liquid can get itself conducted through, if the transformer is actually on and is having huge current in it. So the current can pass through the urine, because your urine contains a lot of salt in it, dissolved salt, dissolved mineral materials, which is going to make it conduct, and it can lead as a flow of electricity through you and then pass into you as electric. So we simply say that electrolytes mainly are substances in liquid form or in molten form that helps in conducting electricity. So there are several other substances too that could be in molten form or in liquid form that do not conduct electricity. Okay, we are not talking about those ones. So those ones are said to be non-electrolytes. Right? But those that conduct electricity in liquid form or molten form are called electrolytes. So the mechanism of electrolysis is based on the ionic theory and depends on whether the electrolyte is in the molten form or aqueous form. So we cannot use non-electrolyte for electrolysis. For example, you can't use sugar solution to make an electrolytic cell, because sugar solution is not an electrolyte, it's a non-electrolyte. You can't use a solution of kerosene or a solution of petrol as an electrolyte. Why? Because they are organic substances, they are not polar, and they cannot conduct electricity. So they are generally classified under non-electrolytes. So, but to support your mechanism of electrolysis, you use electrolytes, which are substances that can conduct electricity. Right? So, and those depend on the ionic procedure or theory, because that is telling us that that are electrolytes, they have that tendency of splitting into their respective ions. That is just a summary of ionic theory, right? So they will split into their respective ions by ionizing, and then these ions will now become mobile electrons, and the mobile electrons carry charges. And this mobile electron will carry charges and then disseminate those charges, right, for utility. So whether the electrolyte is in molten or in aqueous solution, the mechanism of electrolysis can actually be used for that description. Okay. Now, for example, if solution of sodium chloride here as electrolyte, or whatever other electrolyte it could be, when you have sodium chloride solution here and electric current is passed into this electrolyte, don't forget the source of our battery here is a direct current. It's not an AC current. Okay, so it's a DC current. It's very important. Now, when current is passed into this electrolyte, what happens is that electricity passes into the electrolyte, and the electrolyte begins to split into their respective ions. For example, if NaCl solution, aqueous solution is what is used, so NaCl aqueous is going to split into Na plus and Cl minus. Na plus, that's sodium ion, and chloride ion, Cl minus. The Na plus is going to migrate to the of negative pole of the electrode, while the negative ions will migrate to the positive pole of the electrode. So that tells us that Na plus is going to go straight down to the cathode, because the cathode is negatively charged, while Cl minus will move down to the anode, because the anode is positively charged. So that is exactly how the mechanism of any given, electrolyte process occurs. So be it in solid form, be it in aqueous form or in molten form. Don't forget also to put at the back of your mind that when solutions are in solid form, they cannot be used to support the mechanism of electrolytes or electrolysis, sorry. So they can't be used to support ionic theory because ionic theory is only meant for substances in their solid forms or in their molten form or in their aqueous nature. So we can say that sodium chloride crystals will conduct electricity because the crystals are fused together and the particles are not free to move to allow movement of electrons. So, but once they are ionized, either they are in molten form or they are in aqueous form, then that process can actually occur. So that's the mechanism of electrolysis. Next is electrolysis of a molten compound. Now, as I said, in electrolysis, you can do electrolysis of a compound which is in a molten form, or you can do the electrolysis a, of an aqueous solution. For example, if I have sodium chloride and I heat sodium chloride under a very high temperature. So if I heat sodium chloride at a very high temperature of about 600 to 700 degrees Celsius, sodium chloride, and make it and turn the sodium chloride into a molten sodium chloride. That is sodium chloride. Now, this is actually different from me taking sodium chloride and adding sodium chloride in water. If I put sodium chloride in water, what I'm going to have is sodium chloride solution. But if I heat sodium chloride solid, right, under a very high intensive temperature of about 700 degrees Celsius, it's going to melt that temperature. It's going to melt that sodium chloride and make the sodium chloride to become a molten compound. So the first thing we want to talk about here is the electrolysis of molten compound, not the electrolysis of aqueous compound. So let's take them one after the other. Now, for example, sodium chloride is a typical ionic compound because sodium chloride, as we all know, is made up of sodium, which is a positively charged and gives us an ionic compound. So in the solid state, the sodium chloride and the chloride ion in the crystals are not mobile. Why? Because they are compacted together. They are not free to move. But in molten states, that is when they are heated, and the heat is so much that it has that tendency of making it to melt. So the electrolyte produces mobile ions. So they produce mobile ions, which are Na plus as the positive, as the only positive charge ion in the solution, because that's the only solution you have. That's the only plus. And you also have Cl minus as the only negative ion, because that's the only thing present in that's the only negative charge present in your sodium chloride. So why that process is done, heating it under high pressure and passing this over direct current over it. So it's going to split those ions into those molten the molten state of sodium chloride into its constant ions, which are sodium ion and chloride ion. So and that is it. I've explained. So when the direct current is made to pass, the molten electrolyte of NaCl is Na plus migrate because Na plus is positively charged and the cathode is negatively charged. Why Cl minus migrate to the anode? Because Cl minus is negatively charged and anode is positively charged. So the Cl minus will definitely migrate to the anode. Na plus accepts electrons and becomes discharged as neutral sodium atom. Okay? So meaning that our sodium ion is actually occurring at the cathode. It's going to accept electron and then it's going to be reduced. So the process occurring there is a reduction process. And that's why we said at the cathode, what occurs there is reduction. Don't forget the acronym CAO. Cathode for reduction and anode for oxidation. So in the using a molten compound of sodium chloride at the cathode, this is going to be the equation. So our Na plus is actually going to gain electron because what happens there is reduction, and reduction is gain of electrons. Please let's put that at the back of our mind too. When you say reduction, reduction is gain of electron, and oxidation is loss of electron. So our Na plus, which is our sodium ion after it has gotten molten, is going to migrate to the cathode and then it's going to gain an electron. So while it is gaining an electron, then it's going to get discharged. So it's going to be discharged and deposited at the cathode as Na solid, that is sodium atom in the solid form. But the Cl minus, which is the anion, so Cl minus loses electron to become. Don't forget that chlorine, that's chlorine of the chemistry. Now here is the equation used in the description of the overall equation, either for the anode. Okay. Now here we have the Cl minus, as we said, is going to lose electron. So while it is losing electron, it is minus. So let's assume it is losing electron. I'm taking the minus electron that is being lost towards this end so that it becomes plus. So then it's going to form an atom, Cl atom. So for me to be able to produce chlorine gas, what is going to happen is that I need another, another reaction of this nature to make up this chlorine gas. So that's why you multiply all this first reaction by 2 to get this. So chlorine gas is then liberated at the anode and then collected. So, now here is the electrolysis of aqueous electrolyte. The first one we discussed was on the electrolysis of molten, solution, molten compounds. But here we have aqueous electrolytes. The word aqueous comes from aqua, which has to do with water. So in this situation, you add the substance in water to dissolve it. So when the compound is added in water to dissolve it, then it becomes soluble and it can easily form ions when electric current is passed through it. So there are little technicalities or differences between these two. So when an electrolyte is dissolved in water, two different cations and anions will be presented. Because in this situation now, you have two different things. For example, when you add salt in water, what I mean by salt here is sodium chloride, right? Sodium chloride in water. When you add sodium chloride in water, you have sodium chloride and you have water. You have two components or two compounds. So sodium chloride itself has two major ions, which are Na plus and Cl minus. So in sodium chloride, you have sodium ion, Na plus, and you have Cl minus. And in water, you also have two ions. And the two ions present in water are H plus hydrogen ion and OH minus hydroxide ion. These are the two ions also present in water. So meaning that at the end, you'll be having 4 different ions in this electrolytic cell or in the component overall, the mixture overall. So that means you'll be having two cations, which are Na plus from sodium chloride and H plus from water. And we also be having two anions, which are Cl minus from sodium OH minus from water. So in all, we have two cations and we have two anions. So when this occurs, what happens? So let me take this reading quickly. When an electrolyte is dissolved in water, two different cations and anions will be presented in the aqueous solution. For instance, when sodium chloride dissolves in water, following hydrated ions, the following hydrated ions will be presented, which are Na plus and Cl minus from the salt, together with H plus and OH minus from water. That is, the salt ionizes gas. So the first salt, which is Na plus, because it is in aqueous solution in water, is going to give us Na plus and Cl minus. And water itself is going to give us what? H plus and OH minus. So meaning that we have two ions, two cations, and two anions in the solution. So if that is the case, what happens? During the course of the electrolysis, the cations Na plus and H plus migrate to the cathode. That is, both Na plus and H plus will migrate to the cathode because they are both cations. Why the anions, Cl minus and OH minus, will migrate to the anode because they are both anions. At the respective electrode, only one type of ion is going to be discharged. Which one? So what we mean here is that between Na plus and H plus, the two will migrate to the cathode, but only one will be discharged. And also between Cl minus and OH minus, the two will migrate to the anode, but just one will be discharged. So which one of them will not be discharged? So that's the question. So this answer can best be attended to only when we understand the conditions that is required. And that is under what we call factors affecting preferential discharge of ions. So, okay, this apparatus here, before it escaped my mind, is called Hofmann's voltameter. And this voltameter is actually used also in electrolysis. As you can see, a source of energy here, where it is connected, and here we have acidified water. And we can use this to prepare oxygen and hydrogen gas. So the oxygen gas is prepared here, is obtained here, the hydrogen gas is obtained here. We call it the Hofmann's voltameter. It sometimes comes out in question, either in practical or even in theoretical questions. Now, differential discharge of ions. So they're saying that when you have two or more competing ions that are to be discharged at the anode or at the cathode, which one is going to be preferred? So this depends on certain factors, and those factors are the preferential factors that affect the preferential discharge of ions. So there are basically three major factors that determine the type of ions to be discharged preferentially or selectively. When different ions migrate to the same electrode, maybe two ions are migrating to a particular electrode, right? So one of them is going to be discharged based on three major factors. What are they? These are the factors. Number one, we have the position of ions in the electrochemical series. Number two, we have the relative concentration of ions in the electrolyte. And number three, we have the nature of the electrode. So I'm going to pause here a bit and then get questions so that we can see if you're actually together. So if you have questions based on what we've discussed, so let's hear you before the class will end, because I have less than 5 minutes so that we can continue from there in our next class. So if there are any challenge, so let's get to know that. So Brother Abdullah, is I don't know if you can unmute uh, delegates so that they can ask their questions. I can give the response to them. So if you have questions, you can raise your hand, please. So you can be given the opportunity to ask your questions, and adequate responses will be given to their questions. I'm awaiting your questions. Question time. Anybody with questions?
They are all muted. You can tell them to use the chat section.
Okay. Okay, you can use your chat section for raising up questions if you have any. You have less than, you have about 3 minutes to go. So let me do a quick recap since we don't have any question. So today we have been able to talk about uh, an introductory aspect of electrolysis. So let me go swiftly to what we've done today. We talked about electrolysis, taking into consideration what electrolysis is. We said electrolysis is a process whereby direct current enters into a solution of electrolytes, leading to its decomposition into its constituent ions. And then we gave what make up an electrolytic cell. An electrolytic cell is made up of a pair of electrode, positive and negative, anode and cathode, electrolyte, source of battery, and wire. Also, we talked about the cathode and the anode, and then we talked about their utility, that the anode is positively charged and it attracts the negative end of the negative ions, the anions, and it undergoes a general process of oxidation. While the cathode is positively charged, the cathode is negatively charged and it gets itself attracted to the cation. So cathode to cathode, anode to anode, and the cathode undergoes reduction process. And I talked about the acronym CAO, that is cathode for reduction and anode for oxidation. And then we also talked about the mechanism of electrolysis. We looked at the procedure, the principle involved in electrolysis, especially considering electrolyte in its molten form and also electrolyte in its aqueous form, following the principle of ionic theory. And then we looked at this diagram and I explained how it explains the concept or the procedure or the mechanism of electrolysis. And then we looked at the electrolysis of a molten compound and how that also occurs. We take a look at sodium chloride as a typical example, how it melts, and then what is the procedure involved in it when we pass electricity. And we looked at the equations at the anode and at the cathode, and then looked at the overall equation, and then also we did the same thing for aqueous solution. And finally, we looked at the factors that affect differential discharge of ions, and those factors are basically three in number. We said the factors are position of ions in the chemical series, relative condition of ions in the electrolyte, and the nature of electrodes. So that's going to end the class for today. Have a nice time. And I pray God bless each and every one of you. We continue our class in the next week, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.